So we're about to do homework 4B number 9 during the study session before class. Then we did number 8 and found that this 80% was just a red herring. That was explaining why the grams per kilowatt hour was so low in this place. All we had to do was multiply their number of kilowatt hours by the grams per kilowatt hour. The kilowatt hours cancel out, grams is left, and we get our answer. Then we had to change from grams to kilograms since the answer wanted kilograms. So how do you go from grams to kilograms? You divide by 1,000. Maybe you remember from Math 20, these little letters of King Henry does usually drink chocolate milk, or killer hobos dance under dazzling crystal mobiles, or whatever your acronym is. We're starting at the unit, the plain grams, going to kilo as a prefix. So that's 3 scoots left. So we have to do the same in our number, and we get about 187. So that's the whirlwind review of number 8 from study session. We also did number 8 and 4A, but forget about that for now. At least we started it. The 187 we need in number 9. It's saying that a typical automobile's emission is 8.8 kilograms per gallon. This car gets 30 miles per gallon. How many miles would they need to drive to equal this annual electrical use we found from problem 8? So it's 8.8 kilograms per gallon. Then we want 30 miles per gallon. We want things to cancel out unit-wise. So there's a gallons in the denominator. We need to put one in the numerator. So every gallon is 30 miles. And then we're going to multiply by some number of miles. Then the gallons will stick around. That's what we want. Gallons or kilograms, the kilograms will stick around. That's what we want, kilograms, kilograms. The gallons will cancel. The miles will cancel. Everything will be nice. So what does this turn into? 187 is 8.8 divided by 30 times y. So that's going to be 8.8 divided by 30, which is about 0.293. It repeats and repeats. Times y. How do we get y by itself? Instead of times, 0.293 will divided by 0.293 is repeating forever. And whatever that is, 187 divided by previous answer, 637.5. You would certainly put 638, right? Okay, questions about that one? Let me look at chat. Lots of people saying here, no questions. Okay. Thank you to someone who did share this in chat when someone else asked. I thought maybe it would be easier to see it written down on the board. Okay, I think I'm going to transition to announcements. I've stuck them here to remind me. So first of all, don't look at weeks 6 and beyond yet. If we tried to, then this is all formatted from last term with me copying Paula's format. It's blah, don't look at that. So just a reminder, that's not ready for you. A second thing I thought of, that this class, as often is the case, has a large number of nicknames. There's a Jacob who goes by Jay. There's lots of people that shorten their name. So if you want your official LCC email and everything to reflect a nickname, you can. If no one has told you this, you go into My Lane and you go to name change information in the personal information box there. And there's a process you can go through to change what name it calls you in the email and things like that. So it's not a trivial process. You don't just click a box. LCC obviously doesn't want people to pretend to be other people when earning grades in classes, but it's not that hard. So if you really like being Val instead of Valerie, you can actually do that officially. So there you go. One of the things we did on Saturday night was to clarify this homework. This chart now is more clear. There's a big jump between the blue bars and the orange bars in winter, but there is no longer a distracting big jump between orange and yellow. So if you are having trouble seeing updated images, then there's web browser tricks for that. On a PC, you do Control and F5. That's the Windows one. And on a Mac, you do Option, Command, and R, in Safari at least. So you may know that you can go to your web browser and go into settings, and there's this option to clear your browser cache. To go faster, all these web browsers remember pictures and things like that from places you've been at for a certain number of days. And that way, when you go back to that place, it doesn't actually ask the remote computer, send me that picture. It just uses the local copy that you've stored. But that means if there's a case where the picture changes, then your web browser might not bother to go look and see if there's a more recent version. It will just use the old one that was saved on your computer when you visited this last. And emptying your cache might be too dramatic. Maybe you don't want to have your computer browser lose all of that local information. So compared to just Control R or F5 or Option R, these keystroke combinations are a little more drastic. They erase the cache, but only for the page you're on. So if there's ever a page that seems out of date or is having trouble or something, that's a safe thing to try. It won't cause any problems to do that. Someone had a good question in email turning in homeworks. They had a bar chart that they had made with Excel, and they wanted to know how to change it into a Pareto chart with the things ordered. So I'm going to show you that. If I was to look at the options, then I can see where is the data range for this chart. It's A3 to A8. So A3, A and 3, and A8. So that's my words. And then the series, the numbers, is B3 to B8. So I'm going to just put that with a different background color to kind of keep track of it. This is not necessary, but this is sort of what the automatic chart is looking at, are these gray background cells. Okay, so far? If I put a number here, then, oh, I am surprised. Usually it won't look beyond its defined thing. That's very weird. Okay, I am quite surprised that it's looking out of my grade area and is automatically expanding things. Anyway, the safe thing to do, to not trust it will do that, is you can add different rows and it will just make the area it's already looking at bigger. but don't put things on top or below because it might not see them. And then you just have to play with it. So the biggest one was already first, but red should be next. So I can copy and paste there. And then blue should be almost at the end. And white should be before those. And now they are all ordered. So I will get rid of that extra row. So make a few extra rows within the area that the chart is looking at, copy and paste things to get them sorted correctly, and then you'll wind up with some extra rows and just get rid of them. So that's how you reorganize your chart if you wanted to make it in order. Anyone want me to do that again? It's not terribly important, but a good thing to know. Okay, moving on. When I look at this week, then there's also a link to the spreadsheet we're building up, this one I just showed you. We have our Get Help forum as always. Everything starts out normal. Come to the Zoom. If you don't, then check in with a study session or let me see your face doing math work. Skim the textbook chapter. We have an activity which we're actually going to work on during class today. There's a discussion forum that's kind of funky. It is not all about math. It is again about salesmanship and describing data. And we'll talk about the validity of this fellow's financial advice later. The homework is a little funky. Let me just give you a heads up on that. For part A for this week, then you're given 2 sets of data. They're not cute like last week with little kids about animals. Now it just looks like a formal chart. And then it asks you about them. And then there's a 3rd set of data, and this chart has more columns to it. So we'll talk about a different kind of chart today. This box makes another chart. Ignore that for now. That's just that if we randomly use this homework in our quiz on Wednesday, and we happen to roll the dice and get problems that need a chart, I don't want to use the same chart. Remember, we change the numbers when we do a homework quiz. So I just have a 2nd set of numbers all handy in case we need it for a quiz. Then your short answer questions are kind of, can something happen? So it should be very similar to 4A, just not as cute. For, why did that load? 4B. Should say 5B. There we go. Then for 5B, there's no moving numbers around. You're just finding specific examples from your own life of these 10 things. So it's a vocabulary test. Do you understand all the jargon we're using as describing data? So if I have written this well, if it's a well-designed homework, it will take you about the same amount of time. If it asks for a data set, then give me numbers. Don't just describe it with words like the days of the week or something. Okay. Okay, question about the homeworks?
I can't really hear Debbie's on teaching.
No questions. Okay, and then
You could take it to the gazebo.
the special thing this week is a math playground. I'm going to talk about that in just a moment. And the to-do list encourages you to not forget our old stuff just because we have a new topic. So answer key and midterm. So keep doing practice midterms. Even if you just do the problems you got wrong the first midterm once a week, then it will keep you up to date on how you have fixed things. Paula's weekly worksheet is more useful than average this week. We might even talk about it in class a little bit. So that's this week. It's very much the same as last week, except if you notice, the types of data we'll use now have numbers and on the first column instead of words. Instead of red, blue, or something like that, then these are numbers with frequencies. Okay, so the new thing is to pick a math playground to do this week or weekend. So they're up at the top with the picture of the kid on the playground. They're also in the to-do thing. And let me just highlight a few of them that are popular. The graph theory one asks you to play with a branch of mathematics that isn't often seen in school. You have dots and lines between them, and you're solving problems and puzzles using these shapes. It's fun to do with family members. My boys have both done it when they were 8 and 12. It's not hard. So if you like playing with shapes and things like that, then that's a fun one to do. Voting has paradoxes. There's a theorem called Arrow's theorem, Arrow's impossibility theorem, that says you can't design a voting system that will always do everything you want. That's a non-math paraphrase. So here we're talking about some voting ideas and giving you some examples of voting situations that seem straightforward, but they actually can't figure out winners very well, and so on. So if you're interested in elections because it was just an election year, then there's some videos at the end. You can learn all about the problems with voting and why mathematically it is hard to have a good election, aside from any issues of politics and the media and things. Clocks and codes. This is by far the most complicated one math-wise, but some people really like playing with codes. So if you start this and get all the way to the bottom, then it explains all sorts of things with exponents and how to, there's videos to help because it's a little confusing, but how it is that your phone can exchange texts that are encrypted, and any computers watching this won't know. How does Comcast not know the contents of your text if you're sending them on a Comcast router kind of thing? So if you want to know about codes, it might be worth it to slog through all that math. If you want to be writing more, then here are mathematical ideas. You have to defend which is the most beautiful. So you would click each of these links, get a sense of what these ideas are, and say which one you think is beautiful and whatever that might mean to you. Error propagation is slightly confusing. Students who do this one often get help from me, but then once they've done it with me a little, it's not bad at all. So if I take some numbers and I make them a little bit bigger or smaller, how much does that change the answer? And how much does it depend on what arithmetic I'm doing? If I put plus or minus or times or divide, which of those will cause bigger errors when instead of the real numbers in the middle, you have slight measurement things? And this is important for all sorts of things in real life. If I'm trying to budget how much I spend on gas driving across the country, then every gas station isn't going to have the same price. There's going to be some wiggling. The numbers aren't exactly what I think. So getting a sense of what kinds of math are resistant to wiggling and what kinds of math just get absolutely wrecked by having the numbers wiggle can help people. If you've never had a good budget for your household, then this playground is an activity that leads you through that. Here is a sample budget, so you don't have to brainstorm all of these categories yourself. It talks a little bit at the top about what counts as a good budget, at least by one measurement, and then you have to fix their budget. A popular one is a comparison. So the what I want, fly to Paris, what I can afford, stare at my dryer or washing machine, I guess it is. Anyway, the average American vacation costs about $1,100 per person, or the average American wedding costs about $30,000. Those are big expenses. So your task here would just be to create one version of a wedding or a vacation that has this American average cost, which we probably can't afford if we're college students, and then another one that actually would be affordable, and describe how you trim from one to get to the second. People who are actually planning weddings or vacations will often pick this because they have to do this anyway, might as well get a homework done. A similar one that happens sometimes, but not a lot, is renting versus buying. So a lot of stuff here talking about issues of renting versus buying, and it asks you to analyze what's better in your situation. The last one that I want to highlight, the kind of catch-all version, is called the Math in My Life Playground. And you're just picking 3 concepts from class and using them. And here at the bottom are 5 examples you can click on, see what people have done in past terms. They go from simplest, not fancy, no pictures, just a graph, to the one I accidentally clicked on first with all the fancy PowerPointy things. You make as much or little of this as you want, but the math in your life is just sort of, I want to pick what to do. These last 2 are hard to do in a remote class. They would be much better if we were all meeting in the same classroom, so I wouldn't recommend those 2. So this week, you're going to work on one sometime this week or this weekend, and then starting next week, we will briefly share things during class. Some of your degrees and programs and majors want you to be able to present math that you have created that's original in a group setting. And so this is your chance to kind of show off. Say, I can do something interesting and fun and talk to people about math. So if we look at the achievements, then there's a few achievements for this. Share what you did with a playground. You can do it with someone else and get another achievement. If you're really into this for some reason, you might do a second one. Things like that. Okay, questions about the playgrounds? Do you want me to talk more about any of them? Feel free to use the Zoom chat to try and get groups together. Say, whatever, the graph theory one looks easy and fun. Who wants to do graph theory with me, or something like that? And I will try and put all of that in the after class email. Somebody asked about at the end of week 2, there was a ludicrous speed and fluency. These are achievements if you want the purple color. One of them asks you to just do a quick multiplication speed quiz. It randomly gives you 2 numbers, so you would write them in. Let me make this a tiny bit smaller so I can move it to the Jamboard. So 67752. And 41522. And then you start multiplying. 2 times 2 is 4, 10, and so on. And can you finish within, what do they recommend, 3 minutes? So very little practical use in real life, but if you're going on to higher math classes, then it might make life easier to not have to pull out your calculator for everything. So if you can do that, then there you go. That could be a achievement. The representational fluency quiz is very different. The idea of what a hundredths is surprisingly robust. So here are 10 different ideas of what 47 hundredths could be that you already know. So this is just a matching activity. So 47 centigrams would be 47 parts of a gram, right? And so on. So after you try all the matching, then you can go to the toggle answer and see if you got it right. And if you did, then let me know and you'll get the achievement. So not required, but perhaps easy achievements to earn. Okay, questions about any of that? Everyone is quiet. Oh, okay. Then I am going to find this. Where's the original, I wonder? Okay, so here to everyone in chat is a link to an explanation of what's happening with GameStop. I promised I would talk about this a little bit. There's also that one, which I thought was funny since I play World of Warcraft. So somebody said, could I talk about GameStop a little bit because it's all in the news and do you care? I'm going to turn off the recording though because this will not age well because who will care about GameStop much later. Okay, I'm resuming recording. Okay, enough about GameStop, back to 105. So last time we started this chapter, we talked about the frequency tables, we talked about bar graphs, we talked about that you could reorder them, and that's called a Pareto chart. We talked about pie charts. We did the fun thing with scissors and paper and tape to cut out the bars and wrap them around the outside and turn a bar chart into a pie chart. And then we left with this little warning that you can certainly do things with computers that look fancy, but they're not always clearer. When I take my bar chart and make it 3D, it makes it a little harder to see how tall they are compared to each other on the top of the screen.
Are you supposed to be sharing your screen?
I thought I was.
No.
Okay, let me start back up here then. Okay, so we did the frequency tables. We did the bar charts, different ways to make them clear. You could reorder them and call it a Pareto chart if that ever helped. You had the pie chart, and we could cut apart the bars and wrap them around. And then we had two warnings at the very end. Taking my bar chart and making it look 3D and fancy just makes it harder to read. And in example 7, somebody is trying to say the big bag is twice as tall as the little bag. But because area is pi r squared, it looks 4 times as big instead of twice as big. We also talked about cutting off the bottom. Do you start at 0 all the time? Do you start at a bigger number? It can exaggerate the data in one way or the other. Okay, so now we're getting to quantitative data. It's exactly the same, except our left column, instead of being words, is also numbers. And this isn't new. We saw this with a histogram of grades last week. So what's the score you get? Ta-da. Really, the only extra issue is that if you just label the bins, it looks kind of funny, right? In this chart, which I'll grab and move to the Jamboard. Then it doesn't really make sense that this gap is 5, this gap is 7, this gap is 3, and so on. If they were just words like blue and green and red, so on, then you could have the bins whatever you want. You could even reorder them. But once your bins are numbers, then you kind of want to make the bottom axis a number line. We'll have the same issues of do you always start at 0, but certainly making it a number line where everything is spaced out the same seems to be more fair. So a histogram is like a bar graph, but the bottom axis is a number line. Everything is evenly spaced out. We saw that before. I'll stick it on the Jamboard in case it makes someone happy. Okay, so far so good. We did histograms earlier in the words about average section. Does this page ring a bell? We talked about this last time. I defined it differently, as a histogram is a bar chart in which each bar counts a different category of things. I like that definition better because it is not requiring that we have quantitative data. It works for last week when the bins were just labels also. Most people call those histograms too. Okay, in the book, they use class intervals for what I call bins. And we already talked about that if you change the size of the bins, you change the shape of the data. So this could be done accidentally, or it could be done purposefully to try and influence what looks typical on the chart. Okay, another example of a histogram and so on. Do I want to do any more about this? We talked about mean and median and mode last week also. Mean was they add them up and divide by how many. Median was sort them and pick the one in the middle. Or if there's 2 in the middle, then take both of them and average it. And then mode, does he do mode? He does. Mode is the one that occurs most frequently, whatever has the most votes. And then he does a little bit more with range and standard deviation. We'll get to that next week. So there's a quick overview of the textbook, which you should be looking at also. I wanted to look at our activity for this week. It's an extra good one, so let's spend some class time on it. Here's a table that has how many times people can snap their fingers in 15 seconds. So each student recorded 2 attempts. If you were doing this yourself, then you could make your own attempts in the bottom box, but we'll just use theirs. So pardon me, I'm gonna distort the screen. I want to make this not so wide for cutting and pasting. And that one I want bigger. Okay. Sorry if that looks ugly on you. So if I want to make a chart of this data, then I need to figure out what size bins I want. It looks like the smallest is 20. So that's where I should start. And the biggest is 60. That's where I should end. How many different bins do we want? The chart is designed to have 6, but we could have fewer than that. So somebody, let's pick something. How many rows do we want? Should we do all 6 rows?
I mean, if we did 20 to 25 and then 25 to 30, we'd end up with 6 rows, right?
Let's see. So 25, 25 to 30, 30 to 35, 40, 40. No, that's not going to be even.
No.
We could just do by tens. 50, 40 to 50, 30 to 40, and 20 to 30, and forget those top rows. So how many are in the 20 to 30 range? So 1, just 1 it looks like, right? How many are in the 30 to 40 range? 1, 2. How many are in the 40 to 50 range? 1, 2, 3, 4, 5, 6, 7. And then how many are 50 to 60? 1, 2, 3, 4, 5, 6. So our total is 16. Then it asks for the relative frequency. So relative frequency means a percent of the whole. So as a decimal, we're just doing part divided by whole. So 1 divided by 16, 2 divided by 16, 7 divided by 16, and 6 divided by 16.
Can you remind me again where the 16 is coming from, where we're getting that?
Because I added them all.
Ah, got you.
So 0.0625. 0.125. 0.4375. 0.375. Let me fix my arrows. So this was the part divided by whole, and as a percent, we want to write it over there. So we're just scooting our decimals twice. Right into percent. Oops, that's not right. I can draw correctly. So beat 6.25%. 12.5%. 43.75%. And 37.5%. Why would I care about the relative frequency? What's wrong with just the raw count of how many? For finger snapping, probably there's no advantage to the relative frequency. Here's one example. Remember in the homework from last week that there was this question about how many movies to buy? Or is that the, no, that was this one. Yeah, number 8. So what we really want for number 8 is what proportion of 29 that we'll buy should be comedy. So if I have the proportions as percents, then I can say, oh, let's have 37.5% of this match or something like that. But I'm not sure that finger snaps would ever use the percents. Before I move on, everyone okay? You could make this kind of relative frequency chart if you needed to on your own. Okay. Then it asks us to make a histogram. But we had 4 bins going from 20 to 60. The height went from 1 to 6. So I'll start with 6. Halfway is 3. So there's 4 and 5. And there's 1 and 2. Could I start with 0 here? I could. In this particular case, the fact that no one snapped their fingers 0 time doesn't seem really useful data. So 1, 2, whoops, there was a 7. I messed up. So let's do that. Okay. 1, 2, 7, 6. So 1, 2, 7, and 6. I might even want to label them just to make it a little clearer because my artwork is terrible. So let's go back through the steps. We marked the boundaries of our bins. That axis was our first thing. We saw how tall to do this. Then we drew the rectangles above each bin to make the frequencies happen. You did a great job last week with doing this in Excel. This is just testing that you can do it by hand. A lot of you did this by hand last week too. Then we ask questions. What percent of the students had fewer than 50 finger snaps? Well, I could take the fewer than 50 is all of this crowd. I could add those all up and get my answer. So things like that. Does it ask you to do more? Oh, yeah. Things get a little trickier on the homework. Because on the homework, we have some charts with two things going on. And I'm going to steal the same homework chart, but with different questions. So we could ask, what percent are homeschoolers? And we have to look at this chart and say, what's going on? Before, all of our charts just had two columns. Right? It was what were the bins, and then what was the number for the bins, or something like that. Here, our chart has categories. How much are you exercising? We have some people homeschooling and some people not homeschooling. And among each of the groups, how much are they exercising? Not enough, a little bit, but not enough. Or not at all, a little bit, but not enough, or yes, enough. So the homeschooling crowd was 28 people. And they split up their 28 answers in the 3 exercise categories. And you could look at things down going that way. You could also look at things going sideways. There were 26 people that said they weren't exercising at all. And some of them were homeschooling and some of them were not. Overall, there's 70 people. And that's what happens if you add up all these numbers. Do you see why it's only those 6 and not the edges, right? The edges add up to 70 on their own because they include these already. So how would I know what percent are homeschoolers? I want to do part divided by whole. What's my part? What's my whole?
If you're looking at homeschoolers, then the total is 28.
Mhm.
And the part would be the 16, the 10, and the 2.
That's a different question.
Oh, okay.
What percent of the total people?
Oh, okay. So it would be 70 then.
Yeah, so the part is the 28 homeschoolers. And the total people that took the survey was 70. So we get 0.4, about 40. We could also ask what percent of the homeschoolers are getting enough exercises. That's still part divided by whole to find a percent. What are my part and whole this time?
Part would be 2 and the whole would be 28.
Yeah. So it's about 0.07. Or 7%. So you have to read these carefully. What is the whole and of the homeschoolers, of the total? And you have to read the part. And sometimes it's implicit. Before I wrote of the total here, then it was just assumed that the whole was the total. Could I draw a histogram for this kind of thing? Could I draw a bar chart? Then you could, but you'd have to tell me what to draw, which is going on. What am I counting the frequency of? Because I'm counting more than one thing at a time here.
Could all of that information be on one bar chart, or would you have to do like 2, depending on which way you were reading it?
To be clear, you'd have to do 2. You could try and do a fancy 3D thing, but it would be hard to read. So you could do the are we homeschooling bar chart, or we could do the are we exercising bar chart. And among those, you could do the let's talk about homeschoolers exercising bar chart or things like that. And you have to tell me what is the whole and which parts do you care about for each of the bars. That's why for here, unlike last week, we don't ask you to draw a histogram for this because it's vague. Okay, the other thing that makes these kinds of charts different with numbers is we can have hidden multiplication. So do we ask for the, let's get the ages. That's a terrible example because these are categories, they're not specific ages. Let me grab something from the textbook so we have a better example. Okay, so somebody took a test, and here's how often the scores happened in whatever imaginary class this is. So 2 students totally bombed it. 1 student scored 5, 1 scored 12, and so on. Everyone with me so far? Is it big enough on the screen? To find the mean, I want to do the sum divided by how many. But neither of those is really obvious. Let's start with the how many, because that's a little bit easier. So the frequency is going to deal with our how many. How many test scores were there? How do we know?
You add up everything in the frequency column.
Yeah, add all that up. So 2 and 1 and 1, I'm up to 4, 5, 6, 7, 8, 12, 20, 30. Now I want to find the sum. So what was the total of all the scores? What's happening in the top row? How much does that contribute to the sum? There were 2 students that scored 0. Don't think too hard.
Can you repeat the question, please?
Sure. How much does just the top row contribute to the sum of all the test scores?
It would be 2 times 0, so 0.
0. In this row, 1 student scored 5. And as Eli just said, we're multiplying, right? 5 times 1. So for the third row, it's 12 times 1. For the next row, 2 students got 15. So we have 2 15s added to our total so far. And we have 2 16s, and I'm drawing in a different scale than I want to be. Oops, that's a really messy 32. And we have 4 17s. We have 8 18s. We have 4 19s. And 26s. And then how do I find the sum for here?
Do you add up all the sums entirely?
Add those all up.
Yeah.
5 plus 12 plus 30 plus 32 plus 68 plus 144. Somebody else checks this in case I hit my calculator buttons wrong. I'm getting 487. Someone else also get 487.
Yeah, I got that.
Yeah, that's what I
Okay.
get.
So we do the division, we get about 16.2. If you wanted to say 16, sure, go ahead. The general rule for rounding is keep the same number of decimal places, 0 for test scores, or put 1 more on, but don't try and exaggerate your accuracy more. So these frequency tables are really nice for making bar charts, but they're a little annoying for finding averages. But you can do it. I could take the same table and instead ask not the mean, but the median. What will I have to do now?
Well, the median is the middle of the list of numbers. And so if we're looking at the frequency column, would we just start at the top, find the middle number in the middle of all of these, so between the 2 and the 6? Oh, but you're asking for the test score, and so we would look at, let's see,
We would write 0, 0, and then 5, and then
Yeah, it was-
12.
Let me do what Eli's saying. This is the slow way, but I certainly want to do it. So we could just list them all out. We have 2 zeros, and remember we're keeping everything but skipping over the ones that are really small or big. We have 1 12, 2 15s, 2 16s, 4 17s, 8 18s, Did I get 8 of them? 1, 2, 3, 4, 5. Yep. 4 19s. And 6 20s. It's falling off the side. So I could look at this long list that's too wide for my screen and try and pick the middle one, just counting in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gets me to 17. Oops, let me which 17? 1, 2. So that 17 was our 10th. Going that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. That 19 was our 10th going that way. So we need to keep going. 11, 12, 13, 14, 15. Was this 18? 11, 12, 13, 14, 15 was that 18. So these two are the middle. Did I do my counting correctly?
Even if you were off by 1 or 2, it would still be 18.
It's still 18, right? But that was a lot of work, writing out this long list and carefully moving from the edges to the middle. We knew before that there was a total of 30 different tests. The class had 30 students. So I don't actually need to make my blue list.
Would this be where you would do 30 divided by 9, which is the,
I could just say there's 30 tests. So where is test 15? There's 2, plus 1 more is 3, plus 1 more is 4, 5, 6, 7, 8, 12. So here I have 12 tests so far. By the time I finish with 18, I'm sorry, by the time I finish with 8 more, I'll have 20 tests so far. So test 15, that's halfway between, must be during this row. Does that make sense? Let me make that look like a 20 badly. So I could just say that halfway will be the 15th test. And if I go down, then the 15th test will happen during the score of 18. Because if I stopped at 17, it's too early. That would only be 12 tests so far as I count down. If I finished all the 18s, I would have passed it. So it must be hiding in that crowd of 18s. So when you have these frequency tables, you don't actually have to make this long list. You can, but you don't have to. And that's really as complicated as things get. Let's go back and look at our homework for 5A. So we have the cost of textbooks and student ages. Oh, I need to define range. If I ask what's the range of test scores, what makes sense as an answer?
Going to be 0 to 20.
0 to 20, right? The biggest minus smallest. So a difference of 20 points or whatever these are. So the range is from this side. No, that's too big of a. The range is in this column. Don't look at this column and think the range is 8 minus 1 is 7. We're not asking how tall. We're not asking what's the variation of the height of the bars. We're asking what's the biggest and smallest on the axis. That's the range. So which has a bigger range, textbooks that go from $50 to $350 or people's ages. Which outcome has the highest frequency? That's what's the tallest bar. You've done that already. Which outcome would have the highest relative frequency? If I took a bunch of frequencies as their raw counts and made percentages out of them, is it always true that the biggest frequency will have the biggest relative frequency?
Yes.
Yes, right? The total, the whole, will be the same for everything. So the biggest thing that we start our division with will turn into the biggest number over here. It's also asking if I just relabel these, maybe I don't care it's 1, maybe I just care that this is 6.25%. And this is 12%, 12.5%. And this one was 43.75%. And this one is 37.5%. And whether you're counting the raw frequency or the relative frequency, the tallest thing is always the tallest thing. My bar chart doesn't change shape just because I am now making this a percentage on my axis instead of a raw number. Another one, what's the biggest wedge? When you're drawing a pie chart, then all the way around is 360 degrees. So the biggest piece would be 43.75% of 360 degrees. Mean and median, we did an example of. And standard deviation, remember, is how much things change from the middle value. So you don't know how to actually compute this yet, that's next week, but you can look at this and see which one of these is within bounds and which are totally unreasonable. And then this one we also talked about. Let's do the short answers together. Can you have a Pareto histogram?
For the, are we talking for this homeschooling and not homeschooling one, or the above ones?
just in general. So we know what a histogram is, right?
Mm-hmm.
It's where we have bins that are numbers on the bottom.
Yeah.
So can we have a Pareto histogram?
Wouldn't a lot of data be lost?
How would I make this particular bar chart into a Pareto chart? What would I have to do?
The 7 would have to be the first column, and then the 6 would have to be the next, and then the second. So it would disorder the the value ranges on the bottom.
Right, my bins I would have to draw something very funky, right? I could draw a new chart and have 4 bins, and this bin is the 40 to 50 bin. This bin is the 50 to 60 bin. This bin is the 30 to 40 bin. And this bin is the 20 to the 30 bin. And then when I did draw my bars, they would be in decreasing order.
So you could actually have a Pareto chart that was a histograph if your numbers luckily lined up, right?
Right. If coincidentally the earlier numbers were the biggest bars, it could happen. But forcing it to happen doesn't make any sense. So that's the right answer to this one. Could you have one if you lucked out? If the numbers happen to naturally go where the earliest bins were tallest, and then they got smaller after that. How about B? Can you have a negative range?
I don't see why not.
The range is the difference between your biggest and smallest thing. How would you make that?
Okay.
What happens if maybe you could, right? Another way to think of the range is what my smallest and biggest thing are on this axis on my bar chart. What if 0 was in the middle? Maybe I went not from 0 to 20, but negative 10 to 20. What would my range be then?
Then it would be 30.
30. Everyone see why? There's 10 things here and 20 more things here. So there's a difference of 30. So no, even if some of them are negative, it's not going to be a negative range. You can't have a negative range. Can categorical data have a median? So here was this categorical data from last time. People picked their favorite colors. Could you say what's the average favorite color? Why not?
I think you could.
Because it's categorical, they're kind of different things.
A different thing. You could have a mode, which is the most popular, is green.
But there's no way to get like an average of these.
Right. So remember here we had to multiply across each time. 0 times 2, 5 times 1. And after we did that, we added them all up. With categorical data, there's no way to multiply across. I can't do green times 52 is something. And 41 is something. So I can't get this column to add up at the end. So for short answer C, figure out how to put that in your own words. And despite talking about GameStop too long, we are still done 10 minutes early because there's just not that much to this.
I have a question about number 1 on this homework. I think
Sure.
it was on the range. Okay, so you want to know out of which data the set has the largest range. So on the age group, the oldest one is 39 and over. So would we just use 39 to subtract from 15 to find the range? Or when it
Doesn't
says
matter.
over,
What if there's a 105-year-old at that college?
so we have to guess what the over age is? I guess that's what my question is. Is it just says over? So how do we know who the oldest person is?
We don't. Does it matter?
I thought for the range, you want the highest number to subtract
do.
the lowest.
We can't find the range for the second one,
Okay,
but do we need to? It's only asking which has the larger range. What's the range of the first one?
300.
300. So we're not going to have an age difference of 300. We
Okay,
could get into an argument about if we can compare ages in dollars anyway. It's kind of a stupid question. But assuming the question isn't that stupid, then the textbooks will have a larger range.
okay, thank you.
It is purposefully confusing. I'm glad you asked. Yes, someone in chat jokes, we could assign wavelengths to the light and then have numbers to multiply. Asking robots what their average favorite color is. Okay, can I think of anything else to say? Not really. Any other questions? Did we get, the chat was really busy for a while about scheduling study plans and things. Do you need my help with that, or did that get settled?
Can you not end the Zoom meeting for a little bit so at least we can talk together about it?
Does someone want to find a textbook problem they want me to explain rather than how the textbook explains it? None of their examples are really catchy. We could just review. So here is their version of what we just did with the median. So they have income of, what is the income in thousands of dollars of different houses? So 15,000 had 6 times, 20,000 had 8 times, and so on. And the textbook points out there's 100 data values. You could add up all the frequencies and see that there's 100. So to find the median, we just need the 50th one. So we'll start at the top. We have 6 so far in our list. If we were to actually make that long list, 8 more is 14, 25, 42. So the 50th one is going to happen during this column and be $35,000. We don't have to actually draw out 100 different little numbers in a long row. I don't want to get a standard deviation. Okay. Well, I'm going to stop the recording.